See this? This steep rise in elevation? This annoys me. It's annoyed me for years. Why is there such a marked and sudden uplift in this area? What caused this to occur? And why is the direction of it opposite to the typical east to west facing fault systems in Victoria? These were some of the many questions I asked when I first came across this strange geological oddity. But I think I've finally figured it out. And if I'm correct, the implications of it are massive in more ways than one. This is going to be part 1 of a series that I'll be making as I attempt to solve, or at the very least, gain a greater insight into the burning questions I've had for years surrounding the geology of the Ballarat and Creswick region. This story begins with my attempts to decipher a weird geological oddity at Black Hill, which I will delve into in greater detail in a coming video. But essentially, everything began with this point here. This fault. This horizontal line that breaks apart in this section is something that stood out as unbelievably strange to me when I saw it many years ago. In Victoria, one would expect to see the typical east to west facing faults, as a result of the state being formed by multiple subduction events over time that dipped underneath the west from the east, thrusting the land up out of the deep ocean in the process. This is what some of them look like. But now we have this horizontal fault. Years ago, I remember looking at this and shouting, "Why? Why do you exist?" And this lack of understanding would plague me for years. I would wake up at night, soaked in sweat, where I would then proceed to get up, walk to my window, put one hand on the glass and whisper, "Black Hill," until my missus told me to shut up and get back to bed, to which I begrudgingly obliged. In all seriousness though, this fault here is the start of our story, and this story will span beyond this episode. I'm setting the scene for the next few videos, and in one of them, I'm going to reveal the location of a gold-rich line of reef that was sought after for years, but was never found. Yes, you heard that right. I'm going to show you exactly where it is. The knowledge associated with it will be a revelation to literally every prospector or geology enthusiast in Victoria. But to get into it, something pushed this part of the land up by between 40 to 50 meters. This is weird. On top of that, we have a break in the fault, meaning something exerted so much force in this area that it literally snapped this fault in two. And this is the first clue. The second is, well, obvious. Why is this scarp slope so pronounced? If Australia was an earthquake-prone area, I wouldn't be so baffled. But since we get minute ones at best, with us only very rarely experiencing major events, although they still do occur, but they aren't common enough to explain what we are seeing here. So this escarpment isn't formed by a traditional earthquake, and it's not formed by the erosion of soft rocks versus more erosion-resistant ones either, because this is all ancient sedimentary bedrock from the Ordovician era, which was deposited during a time when Victoria was a deep ocean. So the rocks are little more than mudstone, siltstone, slate, sandstone, etc. There's no granitic outcrop or erosion-resistant outcrop that's stopping the slope from being eroded. So what is it? Well, I think it's one of the many Horst and Graben sequences in Victoria. It's the only thing, in my eyes, that perfectly fits and explains this to a T, including the breakaway that's witnessed with this fault, which would occur if something was pushing against it in a northwestern direction. But if any geologists are studying this, I'd be interested to hear what you have to say. The rift event between Australia and Antarctica created the Horst and Graben phenomenon, which I've covered in past videos. One part of the land drops, and the other either elevates or remains static whilst the adjacent block drops. The outcome? Alternating sequences of highs and lows, varying in their level of spread. Some Horst and Grabens are short, others quite long, going for kilometres or more in certain cases. So when Australia and Antarctica separated, Victoria was faulted in a very unique way. For the first time in its history, it was faulted in a north direction. This knowledge is actually pretty new to us, so the implications of it are still being explored. But it explains why this fault snapped here. So let's take a look at the implications here. If the land I'm standing on when I took this video is a graben, then the mountain range that Black Hill is a part of, which, by the way, is called the Brown Hill Range, would be a Horst in this area. Brown Hill was originally a typical east to west facing mountain range, and it still is. But in this area, a north to northwest facing fault was added to it, and I believe that this is why this broke apart in a direction that lines up perfectly with what would happen if massive pressure was applied to it in a northwestern facing direction. In the preceding episodes, we're going to take a look at some pretty fascinating things. Firstly, I believe Black Hill was the site of the original river that predates even the deep leads that run from it. I know that might sound strange, but bear with me and try to keep an open mind, because I promise my reasoning for thinking this is pretty damn sound. On top of this, like I mentioned before, I'm going to show you where a gold-rich line of reef is located, and I'm going to explain why the old-timers missed it. And all of these topics tie into this video, and I believe will explain the deep nature of the leads in Ballarat, with the depth of shafts being ludicrous to say the least, especially when compared to the couple of feet that was required to reach bedrock in places just a little north from it, compared to the dozens or hundreds of feet required here. So this is episode 1 of what I consider to be a fascinating geological series with far-reaching implications. I hope you guys will join me on this journey of exploration and hypothesizing. Make sure to hit that subscribe button and click the bell icon to be notified of when it's uploaded. And as always, thanks for watching. This story is one that intimately ties the complex geology of Victoria with a section in a line of reef that was known to exist and was much sought after, but was ultimately never found. Much effort was placed in attempting to locate it, but the miners and geologists of the time didn't have one crucial piece of information that's required to decipher what is going on here. In this video, I'm going to attempt to solve the mystery of the missing southern section of the Temperance Reef, which was an insanely gold-rich vertical line of quartz that stretched over a long distance, and that, in present day, still exists beneath the feet of many who call Ballarat home. And I'm almost certain that I know exactly where it is. A few weeks ago, when we discovered a gold-bearing reef and started the GoFundMe, I mentioned in the video that I intended to give back to the community, and to begin to release some game-changing info. The link to that video is in the description. Even though we never reached our end goal, I can't tell you how appreciative I am that people so generously donated to help us out. I'm a man of my word. So, this episode will be one of many to follow that will consist of me walking my talk and sharing some of the most valuable and widely unknown information from the many years that I've spent being an obsessive geological nerd. This episode is technically part 2 to the video that I released yesterday regarding the strange escarpment that exists in this region, and it's worth watching that first before proceeding, as this is centered around this mountain range here, known as the Brown Hill Ranges. So bear with me and make sure you're subbed so that you are informed when I release these videos. Please do me a solid and hit that like button too. That's all I ask in return for the valuable information I'm going to share with you over the coming weeks and months, beginning with this video. The Temperance Reef was, and still is, a highly mineralized gold-rich line of quartz. It was deposited into the bedrock of Ballarat some 430 million years ago, give or take, during one of the numerous subduction events that occurred here. The part of the reef that was discovered is here, and multiple companies worked it. But by far, the most renowned company was the Temperance Mine, which was the standout quartz mine in the area northeast of Ballarat, known as Narina today, or Little Bendigo in its heyday. The mine produced 1,530 kilograms of gold out of a total of 3,511 kilograms for the whole of that field, meaning they produced almost half of all the gold that came out of Little Bendigo / Narina. But the richest mine that worked this reef was the Band of Hope, situated just a little north of Temperance, with them yielding an incredible 2 ounces of gold per ton of crushed quartz, which is insanely rich. Temperance have a street named after them just a stone throws away from where this major mine once operated, and the shaft they used still exists to this day. This shaft was visibly open only a year or so ago, but blackberry vines have grown over it. Even with that, you wouldn't want to hop into this hole for reasons I'm about to mention. For well over 20 years, this company worked this reef down to the deepest depth out of any mine in Ballarat, with them approaching 1,000 feet in depth, or almost 305 meters, and the gold was damn good. But this story is less about the company, and more about the mystery regarding why this reef suddenly disappeared from this point onwards. In the book The Astonishing History of Ballarat, Volume 3, the following line appears. The Temperance Reef was worked from about 1853 to 1893, when it was found that its continuity going south was broken by a cross course, beyond which, I believe, it was never traced. This cross course is what I will address in this video, but as you will see, multiple attempts were made to locate it. The first company that tried and failed was the Express Quartz Co., located here. The owner of this mine got into a conflict with the boys from Temperance, and was tarred and feathered in one instance after being beat up when attempting to literally encroach on their claim in the most disrespectful and forceful manner imaginable. He kinda deserved it. Eventually, the Express Quartz Company began operations, but soon failed, and the claim and the mine was bought up by the Temperance Company to be reborn as the South Temperance Mine, after which the trail goes cold after 1875. It too had failed in locating the southern section of the Temperance Reef. Other attempts were made by these men to locate it, with 2 other shafts being sunk to the southwest of the South Temperance Mine, and they were also called South Temperance Mine. But again, nothing came of it. The last mine that attempted to intercept it was the Russell Square Co., which worked ground post-1880s that was associated with the famous Eureka Deep Lead, roughly 30 years after it was discovered. Their intention was to reach this deep lead and 2 suspected tributaries, to get any of the alluvial gold that earlier miners missed. And along with this, they sought to find the missing Temperance Reef, and were expected to as well, with many people confident that this was exactly where it ran, and that the company would find it any day now. Well, they didn't, and you're going to find out why in a moment. This bit of knowledge that I'm going to share with you is a game changer, especially if you're a prospector or miner. But if you're like me, and you just love geology and the ability to interpret the land as much as I do, then this information is also essential to do that with any level of accuracy in Victoria. So whilst this concept is being applied to a very deep mine in this video, it's also applicable to shallow ground, and the implications of it are truly far-reaching. This information, when appropriately applied, opens up a whole new world of prospectivity in this amazing state. The only thing that's stopping me from proving my hypothesis is the ability to legally sink a shaft to the required depth. Believe me, if I could do what the old fellas did and head to the store, buy some dynamite, peg out a claim and begin blasting, I'd be doing that right now to prove it. But the value in this isn't so much in the reef, at least it isn't for me. It's more in what the implications are regarding how it broke off from the main line, and how it got moved away from it. This information will probably interest the Ballarat Gold Mine, so if you guys decide to get a claim, just remember who gave you the info, and at least give me an infinite amount of free tours down there so I can nerd out on the geology. That's all I ask in return. Anyway, this explanation and the ultimate realization that it provided to me regarding the location of the reef originally began with me attempting to decipher a weird geological oddity at Black Hill. Black Hill was a massive open cut gold mine. Low yielding, but odd in that because it was so extensively worked, it was mapped to perfection. But in the mapping, instead of seeing the typical east to west facing faults, which are to be expected in Victoria, as this entire state was more or less formed from subduction events that dipped underneath the west from the east, thrusting it up in the process. And yesterday's video touched on that, and it's definitely worth watching this video first, so that you can understand what I'm about to say in more detail. Basically, it appears to me that a Horst and Graben event altered this land in recent geological time. When the shafts were sunk to locate the missing Temperance Reef, this valuable bit of information was never taken into consideration, and as a result, the miners never sunk to the appropriate depth when they made their shafts. They sunk it to around the 60 to 90 meter mark, not realizing that this part of the earth, known as a graben, had sunk in recent geological history, whilst the area where they found the original reef was on top of a Horst, an area of elevated land that had become uplifted. So whilst these sections of the reef were once joined, they had now broken apart, and the southern section of it became depressed along with the land, because it lost its buddy to the north, and there was no geological psychiatrist available back then. I mean, because the land it was located on sunk an additional God knows how many meters, and there's a chance it sheared off a little to the east or west. One thing to take into account is the rule of erosion that applies to uplifted sections of land. The higher it goes, the more pronounced erosion is, And the byproduct of this erosion was deposited on the depressed section of land, and eventually it was further buried by recent volcanic eruptions. But it's not only the fact that this southern section of the reef might be, at a guess, 200 meters deep, it's also the fact that erosion was more pronounced on the Horst section, meaning the Temperance Reef that was found and worked was sitting on a section of land that had eroded to a much more pronounced extent than the depressed block, so it's not even clear if this reef was outcropping when this land began to shift. The Express Quartz Co. stopped their sinking at a depth of 76 meters. They'd given up by this point. But really, they needed to sink an additional 100 meters, maybe a bit more, assuming they were sinking on the right location to begin with. And the fellas from the Temperance Mine made this same mistake in their other two shafts. They just didn't sink deep enough. So because of this, the implications are widespread, and they go far beyond just this point. Western Victoria is filled with numerous Horsten grabens. Many rivers were dried up by these events, and many others were sunk deep into the earth. The shallowest parts of the deep leads are located here, and the deepest in the grabens. So right now, in present day, I'd be willing to bet an arm and a leg that the southern section of the Temperance Reef is deep underneath Ballarat East. And if you listen carefully, you can hear it mocking us for our futile attempts to locate it. Maybe one day we'll sink a shaft deep enough to reach it, and we can pay it back for its deception by blasting the hell out of it with explosives and crushing it into mere dust, so that we can extract the value that lies therein. Or maybe it'll be spared the same grisly fate that the northern section of it experienced, beginning over 160 years ago. Thanks for watching. This is the final episode to wrap up the Black Hill series, and we're going to focus on the fascinating fact that this uplifted area was actually once the place where an ancient river flowed. This river preceded both the present-day Yarrowee River and the deep leads that would flow from Black Hill post-uplift in Ballarat, only to be covered by recent basaltic eruptions, leading to the birth of the Yarrowee River that flows through here today. If you go to the Yarrowee over here, it's not hard to realise that this river is actually pretty new, geologically speaking. It's small, and whilst it does widen out as it continues its journey south, and then southeast towards Geelong, it's only between 4 to 7 million years old, which compared to the deep leads that preceded it, is very young. Because before this river, we had several older and much larger rivers that flowed south from this area. These rivers began their life during the Horst and Graben events that Ballarat would inevitably experience as a result of the split that occurred between Antarctica and Australia, which led to this part of the land becoming uplifted whilst the adjacent block sunk, forming new horizontal faults in a landscape that previously never contained anything remotely resembling these. This fascinates me immensely. I believe the reason why the Ballarat, and more notably the Creswick region, had the most pronounced recent volcanic activity occurring are because these areas are located at the very top of the Great Dividing Range in this region, essentially acting like a pinch point, forming much larger and more pronounced faults than what can be seen in the surrounding areas. Whilst the majority of the western and middle parts of the state are volcanic, this region has some of the most eye-catching volcanic features, especially in the Creswick region. This means that prior to the split of Antarctica, this area here was level. There was no uplifted and depressed region like there exists today, and it's possible that this uplift is actually still occurring to a very minute extent. So before the immensely gold-rich deep leads that would flow from Black Hill was the site of an ancient river. At least it was in the southwestern part of it, right here, where this split in the fault occurred. How do I know this? Well, physical evidence to my surprise does still exist, even with the Black Hill Mining Company's pronounced activity of literally pulverizing so much of the quartz that once existed here into dust to extract the gold contained therein, that literal ravines and chasms were created inside a once somewhat typical looking hill. But we have this incredible account, which was probably nothing more than a fleeting observation to the person who wrote it. And he wouldn't have had any idea that over 170 years later, some dude would be making a YouTube video about it and noting just how important this lad's observation actually was. This is what he wrote on October the 31st in 1851, which was the year the gold rush began in Victoria. The Black Hill is a particularly interesting geological feature. A spiral ridge of rocks appears on the southwest face, exposing a vein of quartz of great thickness penetrating clay slate. Nearer to summit is found steatite, greenstone, and mica slate. These again are found at a point in the form of clays and breccias. The quartz, though existing in masses of perhaps a ton in weight, is invariably rounded and waterworn, and in its position generally affording undeniable evidence of an aqueous deposit. This observation didn't make sense to me in my formative years when geology was just beginning to take a grasp on my every waking moment, but I revisited it recently whilst attempting to understand and ascertain how pronounced the Horsten-Graben events in Victoria actually were, and a light bulb moment went off in my mind, which obviously blew my mind and has led to this series. The aqueous deposit was what remained after eons of river action occurred here, and I can tell you right now that I'd do anything to go back to this day in 1851 and see it with my own eyes. This tells me that this section here in Black Hill was the river, and that means that post-uplift the river gravels and associated deposits began to flow downhill to become deposited within the deep leads that would invariably take the place of the ancient river that was now slowly, inch by inch, turning from a river into a hill, and drying up with each passing year. In my eyes, this explains why the gravel pits deep lead existed. The gravel pits has always been a weird geological oddity to me. Why is this deep lead literally filled with so many feet worth of gravel? Why aren't other ones the same? What makes it different to the other leads? Where did all this gravel come from and why is it here? Well, I think that this is the best possible explanation for it. It's still not obvious to me whether or not it flowed north to the Murray or south to southeast towards the sea, but if I was to guess, I'd say it was vertical through this break in the fault, and that would make sense considering the mining activity that has occurred here. But I truly do believe this explains the gravel pits, as once Black Hill began to be uplifted, everything began to flow down into the newly forming deep leads that took the place of this ancient river, and as you can see, quite a few did. On geological maps, no areas list any deep leads beginning here, yet when we go here we can see alluvial work was definitely done, and the miners, perhaps unknowingly, mined what they thought was nothing more than a simple drainage channel, when actually it was the remains of an uplifted ancient river that flowed at a time when this hill was literally level with the ground adjacent to it, and evidence of this fact can still be seen today in the river rocks still located all around this alluvial channel, which prove it was alluvial and not colluvial, which would have displayed much more sharper, more angular rocks. These are 3 perfectly worn down and smooth rocks that I got from the area and brought back home, which prove that an ancient river once flowed through here. As you can see, they are very rounded in their shape, proving this area was the site of an ancient waterway that was an important feature to the primordial landscape and wasn't just a minor creek or small gully. So I'd bet this area had some damn good gold and the lads that worked around here probably cleaned up well. But the description of a spiral ridge of rocks was something that always stood out to me when I read these accounts. Why was there a spiral ridge? How did it form? But now it's clear to me that this spiral was a result of the erosion-resistant quartz reefs remaining whilst the surrounding less erosion-resistant sedimentary and volcanic rocks got broken and worn down around it, and carried away over time, leaving what was once an incredible feature that was mined, and the remains of it no longer exist, unfortunately. This Horsten-Graben action more than likely depressed the many deep leads that would inevitably be mined at a depth of several hundred feet during the gold rush. Unsurprisingly, this form of mining was ridiculously dangerous, and it's also more than likely why Ballarat has a significant amount of erosion, with it being insanely gold rich, but containing gold reefs that are actually pretty low yielding per ton, which is perhaps unsurprising to anyone who watched the previous video that I made on this, which explained this phenomenon. Link to that in the description. And all of this has occurred because this landscape has been continually uplifted, and is located at the very top of the Great Dividing Range in this part of the land. And the higher a mountain rises, the more pronounced the rate of erosion will be. So today, this mighty hill has almost no indications aside from these water-worn rocks that a flowing river tore through here. But when the early observations of this place were noted, it invariably shows the fact that this was indeed the place where an ancient river flowed eons ago, during a time when Victoria was a very different place, well before the deep leads, which in themselves are ancient enough. But who knows how long it existed here, and what existed before it. But those days are all gone now, And all we have is this incredible mountain range today, and the old accounts of those that once trekked through here and initially observed it in its original pre-mining state, all of whom have since passed. Thanks for watching. Australia is an incredibly resource-rich country, with bountiful amounts of gold, silver, copper, iron, rare earth elements, platinum group metals, and the best damn opals you can find on our planet, and this is to name only a few of our noteworthy resources, because in reality, we basically have it all. But even though we are one of the largest iron exporters in the world, that iron is coming from the exceptionally ancient land of Western Australia, and is actually a completely different form of iron ore to the one we're going to cover in this video, in that it's far more pure, and the type of process that formed the ore body to begin with actually no longer exists. But iron in Eastern Australia? Well, that's a different story, because it's the youngest part of Australia, with it being little more than a deep ocean 500 million years ago. So where did this iron come from then? We're going to attempt to answer that question in this video, and we're also going to take a closer look at this site and discover why its existence is so strange and so unique to begin with in this part of Australia. So I'm here in an area known as Lau in Victoria, Australia, and this is the only iron mine to have ever been attempted in Victoria. And for a good reason, as economically viable iron deposits really don't exist here. But the fact that we can find it here means they're the kind of iron deposits that aren't exactly high quality, to say the least. And why is this? Well, because it produced pig iron, which is the name given to a crude form of iron that contains the highest amount of impurities, and is therefore the cheapest as a result. The fact that this iron mine was even attempted to begin with is quite incredible, honestly, but there was a logical reason for its formation. The gold rush that occurred here in the mid to late 1800s saw the need for lots of iron for a magnitude of differing reasons, from railway construction to machinery and more. And even though pig iron was crude and impure, it was more than suitable to do the job. But even with this, the mine didn't last long. Within a decade, the company went bust, with the mine opening in 1875 and closing in 1884, and any further attempts to reopen it in the future would prove unsuccessful. This mine also had a smelting works on site, but in present day, not so much is left apart from the insanely large chimney that they built here. But I gotta admit, it must have been fun being the miner who was responsible for heading downhill, as they would fly down it along with a minecart that was filled with iron ore, in order to unload it before making the journey uphill again. Now, as you can see, this chimney hangs pretty precariously, and probably doesn't have many decades left. The entire chimney was actually once wrapped in an external layer, that unfortunately no longer exists. And there used to be a bridge that connected to the top of it as well. And look at those massive iron-rich rocks that they used to line it. Unbelievable stuff. Those rocks are actually the hard rock version of the ore that these guys were mining. During my studies into this operation, I couldn't find anything regarding what type of mine this was. Was it a hard rock one, meaning they pulled solid rock out, crushed it, and extracted the iron through smelting, or an alluvial one? But the moment I got here, it was obvious to me that this operation was most definitely an alluvial one, meaning they found an ancient waterway and they were mining the soil-like particles of iron that had eroded from the surrounding ore, which they readily scooped up by the shovelful and threw into the furnace, alongside some locally sourced limestone from a nearby ancient coral reef to use as a flux, and locally sourced charcoal, which was created by the mass felling of the old eucalyptus forests that stood here in abundance, much to my dismay. But I get it, you gotta do what you gotta do, and life in the 1880s was harsh and unforgiving, especially in Australia. But as you can see, they were chasing the curvature of an old stream. Rounded quartz exists here, but not much, meaning they mined this for gold and took much of the quartz along with any other cobbles before separating it from the gold. And this makes sense, as gold is what they were chasing to begin with, which more than likely led to this discovery of iron ore. The fact that this quartz is exceptionally rounded tells me that this was either a very long-lived stream or a major one. It seems to be the latter rather than the former, and you can see that the miners left the rocks on either side of the riverbank behind, and these are the rocks that the alluvial iron is eroding from. But why is iron here to begin with? Well, this is the fun part. The geological setting allowed for the decomposition and accumulation of anything that lived and died, along with anything that was eroded from here in the past 400 or so million years, since it was uplifted above dry land from the deep sea where it once lay. And this area has always existed as a kind of bowl shape topographically. Recent lava flows have offered quite a bit of infill, though, which obscures the real topographical nature that existed here throughout much of history, as this whole area was more or less one big dome shape from west to east, from here to here. And it still is, even with the recent wave of volcanism, which added some 50 meters or 164 feet worth of volcanic material in the form of lava flows. And the river systems here seem to have always run south. So in the past 7 million years, the land became dominated by volcanic eruptions, which released an immense amount of lava, building up and covering much of the ancient land that had more or less existed in the same state for the past 300 million years. And one way of gauging just how intense this really was is by looking at this big shelf of basalt over here. As you can see, this valley is cut very deep, and the land here is pretty damn steep as a result of that. But the lava flows that form that shelf used to reach all the way up to where I'm standing and above it when they were freshly released. The Moorabool River has cut through the basalt in time like a knife through butter, and after the basalt was eroded, it continued carving through the ancient sedimentary layers, forming this valley. Before this land was a dome in its shape though, we had sedimentary material that was deposited in a deep sea setting, the accumulation of which begun around 550 to 600 million years ago, with this sediment flowing east from the shorelines of the ancient supercontinent of Gondwana. The origin of these sediments occurred from rocks in South Australia and Antarctica, which was joined to Australia back then. These deep sea sediments would eventually become uplifted, beginning around 500 or so million years ago, and after multiple tectonic events, it would eventually be thrust out of the sea. One of these tectonic collisions was a continent-to-continent collision, an event that's known for creating pronounced mountain ranges and for forming major intrusive batholith magma chambers, which bubble up and coalesce deep within the Earth. This collision was that of the microcontinent that Tasmania sat atop, and it collided with this part of Victoria. This collision led to the inevitable fusing of Tasmania with Victoria. To the west of here, we have the beginning of the Brownhill Ranges, which is marked by a major reverse fault, and is one of the many lines that mark the site of an ancient subduction zone. And these ranges mark the western extent of the dome. And to the east, we have another major fault, created when Tasmania collided with Western Victoria, which only served to further crumple and buckle the surrounding area, producing uplift and creating tremendous mountain ranges that once stretched high up into the sky. This iron mine is located just west of this major fault, and even though the land within the dome is mountainous, and was once a far taller and much more mightier mountain range, it had always been dwarfed by the mountains to its east and west, making this area more of a basin of sorts, even with it being mountainous, as surprising as that sounds. The dome-like structure of Lau Lau and the surrounding area really began 360 million years ago, following the collision with Tasmania. As the tectonics here began to settle down, massive waves of magma intruded into the crust in the final stages of this continent-to-continent collision. And this magma baked the sedimentary rocks that were on top of it, transforming the rocks into something known as a hornfels, which is a label given to a rock that has been metamorphosed as a result of high heat but low pressure being applied. And this type of thing occurs when rocks make contact with magma. So after this intrusion, 360 million years ago, the land more or less became geologically stable around the 300 million year mark, where it remained up until the recent volcanic eruptions that suffocated out the ancient landscape occurred. By this point, erosion had really worked the ancient mountain range that existed here down. So much so that the underlying, now solidified magma chamber, which is the guy we spoke of who intruded here 360 million years ago, became exposed to the surface. And in various areas, the highly weathered granodiorite and granite rocks that once churned within this deep magma chamber lie in plain sight. When we view this massive magma chamber on gravity, we can see the aforementioned dome-like shape. And geez, it was massive. This was a gigantic, almost circular magma chamber, And because it solidified beneath the earth rather than erupting, it's known as a batholith. This batholith was once located many kilometers beneath the surface of the earth when it was active, showing just how much erosion has occurred here over time. Now that we have the geological and geographical setting down, we can discuss how these iron deposits formed to begin with. Along with them exist deposits of brown coal, and both are linked in an indirect manner, as both of these deposits require a depositional environment for them to form to begin with. Meaning both the brown coal in Lau Lau and the iron deposits require an area where material was allowed to sit and accumulate for them to form, as opposed to them being transported out by the waterways, like what would occur in a well-drained area. So this entire bowl shape was and still is an area of stagnation, meaning anoxic or oxygen-less conditions prevail. As you can see, the town of Lau Lau has areas of major lake deposits, showing water is still sitting here rather than leaving. So it's evident by these deposits that this area was one that was dominated by swampland, lakes, and subtropical to tropical rainforests throughout most of its history, as coal is the result of the partial decomposition of plant material that's subject to increased pressure and temperatures that occurs in an airless environment. Which essentially means things died, then more things died and covered up those things, then even more things died and covered up those things. And layer after layer of organic material gets built up over time, and the pressure inflicted upon the bottommost layers by that or by any tectonic element eventually turns this biological material into brown coal, but only if it's in an anoxic environment. So this area was definitely one that was dominated by swamplands. When this part of Australia was closer to the equator, this area became tropical, and as it drifted away, subtropical. And that was when much of the iron-rich limonite deposits were formed. Limonite is an iron ore that is actually a mixture of different iron oxides that have been weathered out of a host rock, and that accumulate as a result. Because iron has a heavy specific gravity, it tends to accumulate, and their heaviness makes them resistant to being transported out by water. And because its existence is one that's formed as a byproduct of something, that makes it a secondary material. The actual meaning of the word limonite in ancient Greek is wet meadow or marshy lake, and this is because limonite is also known as bog iron ore. And bog iron was a very important early form of iron ore that humans mined during the BC times. But the fact that it's associated with the many marshes that exist in Europe is where bog iron got its name, and it serves to further highlight the swampy anoxic conditions that prevailed here. This land is one that is more or less stuck in a dome-like shape, and this is what was necessary to form part of the limonite, aka the iron ore, which was derived from two sources. The first was from organisms known as iron bacteria, which convert ferric to soluble ferrous salts in conditions free of oxygen. The second is from the erosion of the very same quartz reefs that the miners were already chasing for gold. Only it came from the minerals within these reefs that were ignored, and in some cases despised, as pyrites, which is also known as fool's gold for the fact that it does look very much like gold does, thus its nickname, occurs in these veins. But it, along with other iron-bearing minerals, became oxidized and hydrated as erosion slowly worked to whittle the quartz reefs that they were contained within down over time, and these iron-bearing minerals would become deposited and would accumulate within these acidic swamplands and the stagnant, barely flowing streams. And in time, they would be turned into limonite deposits. Now, it's kind of been a goal of mine to accumulate and smelt some iron for years, so if you'd like to see a video with me attempting to do that, let me know by clicking the like button. I'll use some of the same alluvial material that these miners used. This deep red soil that's just saturated with iron. The soil itself is literally just rust. But yeah, limonite is basically a blanket term to describe an ore that's an accumulated deposit of many different iron-bearing minerals, and in general they're a combination of hematite, magnetite, and pyrites. These iron deposits are the result of both bacteria, alongside tens to hundreds of millions of years worth of erosion that occurred in a basin-like topographical area which allowed for the accumulation of virtually anything that died, and anything that weathered or eroded. A truly fascinating origin story. These iron deposits aren't really valued today, but during the Iron Age, around 1200 BC, our ancestors would have absolutely killed to have had access to this, and we know that for a fact. Damn murderous humans. So this is the story of the iron deposits in Lau Lau. Now these aren't unique. and I've seen many areas in Victoria that were saturated with similar looking iron deposits. But this was the only place where this type of endeavour was ever attempted, and it's looking like it's going to stay that way for a very long time. Thanks for watching. One thing that I hadn't done, much to my astonishment, was explore the islands between Tasmania and Victoria using magnetics. I know, right? What on earth have I been doing with my f***ing life? I've been squandering time, but for some reason this morning it struck me that I hadn't done it yet. So I downloaded the magnetics layer and activated it, and voila, there it was, like, hey dude, you found me. And indeed, I have found you, Mr. Cheeky Volcanic Arc. No arcs can hide from the scrutinizing gaze of Mr. OzGeo. But now that we've illuminated this undoubtedly very ancient volcanic arc, we'll try to unravel the geological narrative behind it. To my knowledge, this hasn't been done yet. I've combed through the scientific literature. My eyes are as red as Cheech's right now from staring at the screen all morning. Dozens of articles, hundreds of pages from our good friend et al. And guess what I found? Nothing. Not a single mention of this volcanic arc. And nothing even came close. Am I surprised? No. I've said this many times before, Australia is underexplored. Geologically, it's still a land of new discoveries. So either this hasn't been discovered, or it's been seen but not deemed worthy of investigation for some reason, or something else. But this right here, without a shadow of a doubt, is an ancient volcanic arc. I know this because I've discovered numerous previously undocumented arcs using geophysical methods during my time on this magnificent Earth. And as is the new usual, this video has also been turned into an article which you can read on ozgeographics.com. So I won't claim to be the first to discover it or anything like that, but I found an ancient volcanic arc in the ocean near Tasmania, and I did all of this while taking care of nature's call. The wonders of the 21st century. About 1.6 billion years ago, Tasmania was born. We now refer to the microcontinent that encompasses Tasmania as Van Dieland. It's more accurate to say Van Dieland was born, and it did its own thing for about 1.1 billion years, just drifting around the globe, colliding with places, rifting, accreting, you know, all that good stuff. Around 430 million years ago, it slammed into Western Victoria, causing a continent-to-continent collision, and approximately 360 million years ago, the system finally shut down, and it's been part of Australia ever since. But this volcanic arc is much older than Eastern Australia. It's definitely twice its age. This is a very ancient subduction zone. In fact, it appears that King Island's origin is actually one that sits atop a series of volcanic arcs, but its oldest rocks are the metamorphosed oceanic sediments from as old as 1.6 billion years ago, proving that King Island has always existed alongside Tasmania since the very beginning. But as you can see, we have got this one off the coast, and we have another arc here in the southwest. It's primarily buried by recent erosion-related sediments, except for a few key areas where it outcrops in the form of different volcanic rocks, ranging from intrusives to ancient extrusives. And one can tell something significant happened here simply by looking at the complex faulting that's occurred here. But whatever happened here did so about 600 million years after Van Dieland was born. And it may seem like nothing but a small island, but this place has seen some things. From the evolution of complex life to the first plants and beyond. It's witnessed every extinction event, and its inception might have been just as destructive. But now it just sits here. No name assigned to it, to my knowledge, lying buried beneath the waves of the Bass Strait, and beneath the sediments on King Island, with some outcrops here and there that hint at the true origin of this land. It's very possible that Aboriginal eyes gazed upon the now submerged volcanic arc before the waters here rose to inundate the land. Now the rocks here have all been dated, and we have areas where rocks associated with the arc are outcropping. So as you can see, something happened between 1 billion and 540-ish million years ago. I'm still trying to ascertain what exactly happened, and it's quite complicated to do so when you go back beyond, let's say 600 million years. But so far, it has to be one of two things. Either King Island was a back arc basin, that being the area behind the volcanic arc where the land experiences a zone of rifting, leading to the formation of highly explosive volcanoes and supervolcanoes, or, and my bet is on this one, this has experienced a rift event recently as part of the Port Phillip Sunklands, meaning King Island may be where it ends. I made a video on this a few days ago. Basically, I formulated a hypothesis based on some solid evidence that the recent rift zone that occurred and that stretched Melbourne apart so significantly within the past 30 million years did so as a result of the recent continent-to-continent collision that's occurring in New Zealand, which I postulate has effectively stretched the land apart. And based on magnetics, it appears the rift may venture as far south as King Island, meaning this area of blue is more than likely a recent occurrence. It's likely that before 100 million years ago, this entire area was comprised of relatively tight-spaced volcanic arcs that have now been separated, showing this V-like line over here. Something wacky is going on here, and I'm going to guess now that the models of Victoria in 20 years will be completely different from what they are now if it's discovered that this rift event is still active, which I honestly really do think it is. Now, the part of the island with the most exposed section of the arc would be the northwestern part. Here we have ancient granites ranging from 545 million years to 1 billion years old. Now, interestingly enough, we have an amphibolite metamorphic complex here. Without going too much into it, it's one of the many classifications that list rocks based on the pressure and temperature grade they've been subjected to during past metamorphic events. Amphibolite is more often associated with continent-to-continent collisions than it is with subduction events. However, they can still occur during subduction. It's possible that this occurred when Van Dieland collided with Australia, long after the arcs had gone extinct. Either way, it shows this land went through a marked degree of compression and metamorphic alterations as a result of numerous different tectonic events experienced over time. In the middle of the island, we have thick-bedded quartzo siltstone from as old as 1.6 billion years ago, up to around that same number of 545 million years, suggesting this area has always been some kind of depositional feature like a basin or deep ravine, possibly an ancient rift zone. Now, things get interesting again around the 400 million year mark. Van Dieland collided into Australia 430 million years ago, and we can see that it's restarted the magmatism here. We have magmatic intrusions that occurred. One did so in the northeast, emplacing this monzogranite and granodiorite layer. You can see it occurred around the time of the collision, and existed throughout right up until the end. This collision was quite intense though, so it's no surprise that intrusions continued long after it had ceased. And this is evident by the porphyritic monzogranite that continued to intrude here in the southeast from 354 to 298 million years ago. Now, I don't know what type of exploration has been conducted on King Island, but I'm actually quite surprised that no gold discoveries have been made, and I'd bet $1 million if you got me on that island and gave me permission to dig, I'd fucking find gold. 100%. But the metals we do have right now are indicative of intrusive and volcanic arcs like tungsten. So I can tell you right now, King Island has had a tumultuous history, and there'd undoubtedly be valuable minerals within the soils. And the surrounding, now submerged land, which is more than likely rich with alluvial gold among other metals as a byproduct of the immense tectonic history that has unfolded here. This and the associated arcs are giant. Their size shows it was a major system. But this is just one of many anomalies I've come across this morning. In fact, there's an amazing geological story that lies obscured beneath the waves of the Bass Strait, and that is now only visible due to magnetics. Let me know if you like this type of video where we use magnetics to attempt to ascertain what geological processes have occurred to underexplored lands that lack any study at all as it pertains to the arc or any other geological feature. If you'd like to see more, let me know by leaving a like and/or a comment, as I'd love to turn this into a series. This is the part of geology that I absolutely love and am deeply passionate about. So I hope you enjoyed this video that delved into the ancient volcanic arc that roared ferociously in the once barren and lifeless soils of primordial Tasmania, Van Dieland. And here they still stand, a testament to the immense tectonic and volcanic forces that shape our planet. Thanks for watching. If you watched a video I made 2 days ago, you'll remember we had quite an exciting discussion about the mineralization of King Island. I even went off script and made a bold claim. I bet $1 million that we'd find gold there if given permission to dig. Well, today's video will be a thrilling follow-up to that claim, and not a single shovel needed to be plunged. A subscriber sent me a link to an article from the 1870s discovered in the Trove Archives, where a child found gold on King Island. Thank you so much to the sub who did that, by the way, I really do appreciate it. And it wasn't just a speck or two, it was determined sufficient in amount to render it payable. The discovery didn't really raise too many eyebrows at the time, as this was 20 years into the gold rush of Victoria and no one was keen to leave the state known for the largest gold nuggets in the world to go to some random island that may or may not have a lot of payable gold on it. The purpose of today's video is to demonstrate how a background in geology can help you understand the mineralogy of a place without ever setting foot on it. And all of this is attainable with a little bit of self-study. It's a fascinating field that allows us to read the Earth's history and predict its hidden treasures. So without further ado, let's look into this discovery, where it was made, the geological processes that formed it, and how I knew gold was here to begin with. Firstly, you'll always find gold in some form where there have been tectonic collisions. This is due to hydrothermal fluids and the emplacement of mineral-rich waters that percolate and solidify into quartz within the many faults and fractures in the bedrock of the slowly deforming land. In the last video on King Island, we discussed a tungsten mine, but upon further reading, I discovered that tin mines have also operated there. Tin is typically found in cassiterite, associated with granitic magmas. Unsurprisingly, tin is heavily associated with volcanic arcs. And if you recall, we discovered a volcanic arc on King Island, with granite outcropping as the predominant volcanic rock here. It's worth noting it's not exactly clear whether or not this granite was outcropping pre-30 million years ago. It's possible its exposure to the surface was due to the proposed rift event that I spoke about in the previous video. The volcanic arcs may have been torn apart into the V-shape that I showed on the infographics in that video, unveiling a granitic basement. This granite is the magma chamber that fed the arc. Only they solidified beneath the earth when this system finally shut down, and they could never accumulate enough pressure to erupt onto the surface. So here they are, ancients lying frozen in time. Now let's talk about the gold. It was first discovered on the northernmost tip of the island. This isn't surprising as the ancient granite has been exposed in a good section of it. This is the bedrock layer, so any eroded gold would sit right on top of this granitic layer, and indeed that was the case. But here's where things get even more interesting. I postulate there are two forms of gold on King Island, those of volcanic origin and those shot up through hydrothermal processes. When I say hydrothermal, I basically mean the typical quartz veins that we associate gold with. The proper term for this type of deposition is known as orogenic gold deposits. These veins were emplaced into the bedrock during the subduction events and the subsequent mountain building episodes. On the other hand, volcanic gold is tiny to microscopic, but present, sometimes in payable quantities. It tends to be lower yielding though, with ore generally yielding a few grams to the ton of crushed ore versus the half an ounce to an ounce one would hope to obtain from hydrothermal veins. However, this is only sometimes true, and highly concentrated volcanic gold deposits exist, generally as a result of re-enrichment processes. Gold is usually found alongside a host of other metals in volcanic ore, such as copper, silver, lead, etc. Hydrothermal veins may have a mixture too, but their overall composition is less diverse and more focused, so to speak. There have been 2 gold-bearing veins discovered on King Island that I've read about. I've only found 3 articles on this subject, but prospecting licenses were indeed taken out. It's yet to be known what work was done though. There's both alluvial and hard rock work that's been conducted, but I'm unsure of the extent, and I'd only really be able to ascertain it if I personally stepped foot on King Island. The first gold-bearing lode was the one discovered with the initial discovery. A boy found gold while out kangarooing. The reef itself was 12 feet or 3.6 meters thick, and it ran quite a distance, venturing out into the sea and beyond reach after that point. We'd also have some very interesting mineralogy occurring here because of the limestone hills that make up many sections of King Island. Carbonate gossans are strange and fascinating. They're a subject I have yet to have the opportunity to explore much because of their lack of existence in the areas that I've lived. I might have to go to King Island after all, because carbonates can host a variety of mineral deposits. Lead, zinc, copper, gold, iron, fluorite, phosphite, barite, rare earth elements, and even radioactive minerals, which I'd prefer to stay the hell away from. In the article, the texture of the gold is mentioned. It's said to be flat and very worn, appearing as though it had been conveyed a considerable distance. This line is sticking out to me like a sore thumb, and I'm going to ponder it in the coming days to understand it more. I know that this gold is very ancient and was deposited eons ago. But this description of it appearing to have been conveyed a considerable distance seems to be something important to me that I need to keep in mind for a later date to better understand the geological history of King Island. The fellas who made this discovery took 3 weeks to find their first speck of gold, and as usual, they did so right as they were about to leave. The typical prospector's luck. But I hope this piques the interest of prospectors out there to attempt to understand more about geology, because it really is the pinnacle for discovering mineral deposits, among so many other things. Geology has single-handedly changed and enriched my life in so many ways, from altering how I view the world to helping me make discoveries or have an eye for identifying potential findings when they're present. In a coming episode, I'm going to introduce you to something I like to call hidden volcanoes, of which I've found a few on King Island. I hope you've enjoyed this exploration of King Island's geological history and the fascinating world of mineral deposits here. Remember, every rock has a story to tell. You can uncover these stories and make incredible discoveries with some knowledge and curiosity. You'd be amazed at how many people walk past seemingly ordinary, boring looking rocks, only for some nerd like me to come along, pick it up, and stare at it intently for an uncomfortably long duration before deducing potential value when making a discovery. Recent history is filled with stories of discoveries that were made this way, and I've personally made at least 2 discoveries in my lifetime in highly explored areas that, for whatever reason, overlooked something that stuck out to me. So keep exploring, folks, and remain curious and hungry for knowledge. Discovery is still out there for those determined enough to seek it, even if it's done in a toilet stall on your phone whilst going number 2. It's still a discovery nonetheless, and when you hit flush, you can do so with added satisfaction. Thanks for watching. Today we're diving deep into a fascinating geological phenomenon that I've come to call shadow volcanoes. This isn't a term you'll find in a textbook, it's one I've coined to describe a curious and largely unnoticed aspect of the geology of Eastern Australia, including Victoria and Tasmania, and the islands in between. So let's dive right in and demystify what these shadow volcanoes are all about. Our story begins around 85 million years ago, when the continents of Australia and the newly forming continent of Zealandia, where New Zealand lies, were separating from one another, a geological event that gave rise to the Tasman Sea. This separation, or rifting, as it's called, caused weaknesses in the Earth's crust, creating pathways for magma to upwell from deep within the Earth and erupt onto the surface. This resulted in numerous volcanic eruptions, particularly in what is now Victoria, which spewed copious amounts of fast-flowing lava onto the land, creating what we now call the older volcanics. Fast forward to roughly 30 million years ago, Australia is moving north ever more. It slowly moves over a so-called hotspot, an area within the Earth's mantle from which an abnormal amount of magma rises. This hotspot resulted in a series of volcanic eruptions. Much like a string of dominoes falling one after another, these eruptions began in northern Queensland, and over millions of years, progressively moved southwards as Australia continued its journey northwards over it, resulting in volcanic activity in New South Wales, Victoria, South Australia, and even all the way down as far as King Island and Tasmania. Now, it's essential to understand the type of lava these volcanoes produce. They were mostly spewing out a kind of rock called basalt. Compared to other volcanic rocks high in silica, such as andesite and granite, basalt isn't as good at resisting erosion. Over millions of years, the relentless forces of wind, water, and ice have worn away these basaltic landscapes, causing significant erosion. In some cases, the volcanic vents didn't release enough lava to form a large permanent structure, so they eroded away quicker. This is where we get to the concept of shadow volcanoes. Essentially, we're talking about places where there were volcanic eruptions in the past, but they aren't listed as occurring on any geological maps. In fact, their entire existence is strangely omitted, which I assume is due to some kind of misinterpretation, possibly attributed to the significant erosion that's occurred in some places or the lack of voluminous flows being released in others. So yeah, as a result, they're not listed in any of the available geological maps, much to my frustration and constant annoyance. I can't even begin to tell you how many areas I've studied that would list the land as being purely sedimentary, only for me to drive there and shout at the fact that there are literally dozens of tiny stubs of highly eroded volcanic vents everywhere. My mates know full well about my annoyance regarding this subject. These little guys were so hidden that it's possible they've remained obscured from geologists themselves. And well, since they're shadows of their former selves, and since they appear to be a volcanic version of a ghost, so to speak, I've given them the term shadow volcanoes. So how do we know these shadow volcanoes exist if we can't see many of them? Well, this is where the science of geophysics comes into play. By studying the magnetic properties of rocks in a given area, we can identify the telltale signs of past volcanic activity, even if the physical evidence has largely been eroded away, and this is purely because basalt is rich in iron, and it pops out like a sore thumb amongst the surrounding sediments and granites. And once we know where to look, then we can go out into the field and search for any remaining physical evidence of the volcano, even if it's just a small stub or rounded hill, which it usually is. And as you can tell, magnetics is no joke. Some of these volcanoes release so much lava that you can make out the conical shape on the magnetics themselves. But others, well, they're cheeky. They hide very well. Check this out. This is the Ringwood area east of Melbourne, right next to the Warrandyte goldfields. I went to my mate's house last week because he wanted me to dig his yard and see if he had gold. I checked geological maps before I left, and as you can see, the Andersons Creek layer is listed here as being purely sedimentary, compared to this layer right here, which is an example of where basalt was identified. The Greensborough basalt layer erupted around 23 million years ago when Melbourne's rift zone was at its most active. So I drive to my mate's place and what do I see? Basalt everywhere. Everywhere! Basalt of varying kinds too, and of varying ages, so we have multi-phase eruptive byproducts here, none of which are listed. This could be basalt from 500 million years ago when Victoria was first born, 20 million years ago when the rift occurred, or related to the hotspot and released within the past 7 million years. So naturally I step out of my car, greet my mate, and immediately crack it over his fence, which is constructed out of the very basalt that was apparently never erupted here, according to geological maps. And to further rub salt in the wound, all of his neighbours' fences were constructed from the very same basalt. So I jump on magnetics, and it doesn't appear like much, true? This could be more impressive compared to that magnetics image I showed you of that massive conical volcano. But let me show you something. The cheekiness of the shadow volcanism is about to be unveiled for all to see. Because these, yes these are all freaking volcanoes. They're either small eruptive vents of varying ages or very old medium-sized conical structures that have been highly eroded. And look at them all, it's sickening. Now, all of this may seem like a minor detail, but it's a significant issue for anyone studying or exploring the geology of Eastern Australia. I've personally encountered this situation numerous times during my career. I'd start by studying a geological map of a particular area, then when I got there in person, I found that the real-world landscape was dominated by highly eroded basaltic rock, not the other types of rocks indicated on the map. Meaning I now had to dig through what could be many feet, or in the worst case scenario, many meters worth of highly eroded basaltic overburden. The implications of this can be profound. For instance, if you're searching for gold deposits, it's important to know whether the landscape you're exploring has experienced volcanic activity in the past. When basalt is in its lava state, it readily flows in a stream-like manner, covering up the older rocks that contain the gold that I am seeking, making them harder to find and more work to reach. These eruptions would often disrupt and redirect ancient river courses too, affecting where gold might be found. And when multiple eruptions occur over a long period of time, temporary streams that form post-eruption get created, sediment accumulates for a period of time, then another eruption occurs and a new river takes over and it changes course again. Meaning multiple placer deposits could exist in the location as a result of the volcanic component, and I need to know that, like, you know, far out. This issue of shadow volcanoes is particularly relevant in mineral-rich areas such as Malayagal and certain regions around the Grampians area. However, the most striking recent example I found was at King Island. Despite the clear evidence of volcanic activity on the island, as indicated by magnetic data, the official geological map of the island does not even include or even state the existence of any recent volcanic rocks occurring here. This discrepancy underlies the importance of acknowledging the existence of shadow volcanoes in regions like Victoria. Their presence can significantly affect the approach to geological exploration and research in these areas, It's a lesson in how our understanding of the Earth continually evolves and how new concepts like shadow volcanoes can dramatically alter our interpretation of the landscape around us. By shedding light on these shadow volcanoes, we can further our understanding and appreciation of our planet's complex and ever-evolving story. So, the next time you look at an unimpressive hill, you could be looking at a cheeky shadow volcano hiding from plain sight. Thanks for watching.